This is Dr. S. Prince Samuel, working as Associate Professor in the Department of Biomedical Engineering at SNS College of Technology, Coimbatore. Now we, the faculty and the students, are gathered here to discuss about the DT activity titled Planar Transformer, the implementation in its medical devices. Based on the 5 stages: empathy, define, ideate, prototype and testing. Because the medical electronics, it plays a vital role with medical products. We have to make it in a compact size generally. Let's start the discussion now.
Myself, Sandeep Krishnan. Me and my teammates are going to present about the uses of planar transformer. First of all, our project is on design and analysis of planar transformer for high frequency resonant converter, LLC converter. Me and my teammates Hariharan, Akash, Dharani and Sudiksha, we are going to present it on it. First of all, why we want to go to a conventional transformer instead of a planar transformer? As we see, conventional transformer are bigger in size. We cannot place in every component, like they are large in size. We cannot place in a charger or in electric devices or healthcare devices. Instead of that, when we go to planar transformer, what is a planar transformer? For simple example, planar transformer is made up of printed circuit board, normally called as PCB. We are going to make a winding, like we have a conventional transformer. We are going to make a copper winding in the planar transformer. We can make it by some of the calculations, like magnetic inductance and magnetic capacitance and the distance between the core. We have to make some calculations on it, and we can wind according like turns ratio in the primary side and the secondary side according to we choose the planar transformer. So, when we for main purposes, we use planar transformer for high switching areas. Like we need like a conventional transformer, we can switch only up to some kilohertz. But for planar transformer, we can run the starting switching itself. It starts from 100 kilohertz. 100 kilohertz to 1000 kilohertz we can transform with minimal number of copper loss. When we go to conventional transformer, like a normal transformer, which are present in our areas. For like 220 volt which come to our household, there are many losses. Like in a transmission line, they will be starting from a high range like 13 kV, but in the end of the day we only receive 220 kV. But we when we go to planar transformer, these are reduced. This can be reduced, the losses can be reduced, and we can take more energy in it. We can use it in laptops, EV chargers, and in healthcare systems. These are the advantages I see when we go to planar transformer.
So, as Sandeep said, the main defined problem of this project is how we can design a transformer which is suitable for high frequency resonant converters. So here are the main problems in the normal transformer is we face proximity effect, we face skin effect, all those things. By seeing the proximity effect, we see an uneven current distribution, and in skin effect we see an increase in AC power transformation. So these are the main causes in the previous things. So to overcome these problems, we use planar transformations, which will reduce the copper losses, which will also reduce the high temperature in these upcoming projects.
Now you see about the different types of ideate, using the better core materials, and also the planar transformer to improve the winding experience, and also the reducing the practice in terms, and that is using the advanced coding data. One of the most effective solution in the planar transformer is in the design, the windings and the implement of the RCB copper tracks, and also the multiple use of the PCB copper tracks.
And we come to the prototype, multi layers of Ferrari's cores and PCB. The core section is made up of the switching high frequency. The comparison of size in competitive transformer and planar transformers is size is in competitive transformers is very big in bulky transformer, and in planar transformers is actually a compactable one, and the cooling of compactive transformer is very high. The low compact of the cooling is very low in planar transformer. We choose only the planar transformer for this project.
Let's conclude this session. Now we have understood the advantages, the main power consumption factors, because medical devices, most of the devices we have to make it self-operated. If you put a separate battery and big size, it will be difficult to wear them, because we have to monitor the parameters, each and every minute, and also a continuous process. It should not be a burden to the person who is wearing this kind of devices. So our aim is to make it the medical devices in a very compact size. For that we have found a super solution based on the DT. We will implement soon, and we will find the patents also soon. Thank you, students. Thank you for the discussion.
Thank you.